Hi, I'm going to talk to you about the Monty Hall problem. So, the problem first appeared on the game show Let's Make a Deal. It was hosted by Monty Hall himself, and it was based around probability. He would pick contestants out of the audience to come up on stage and participate in games. One of the games would be there would be 3 curtains. One curtain would have a prize behind it, and the contestant would have to pick one of the curtains. So, in this specific game, there was a 1 out of 3 chance that the participant would win the prize, right? But the Monty Hall problem was not that simple. So, the specific problem is that there are 3 closed doors. 2 have a goat behind it, and then 1 has a car behind it. And the contestant first picks one door without knowing what's behind it. And then, out of the 2 remaining doors, at least one of them has to have a goat behind them, right? Because there's 2. So Monty Hall would open up a door that was hiding a goat. And so out of the 2 closed doors, the contestant could switch their door or stick with the original one they picked. So there's 4 scenarios with this problem, right? Number 1, the contestant picks a door with a goat first and then switches to a car. 2, they pick a goat first and they stick with the goat. 3, they pick the car and switch to a goat. Or 4, they pick a car and they stick with the car. So, people were wondering if there was a more educated way to go about the problem. So, they turned to Marilyn Vos Savant, who had her own column called Ask Marilyn. The reason she was so popular was that she had an IQ at 190, and that was the highest recorded by the Book of Records in the 1990s. And so people went to her for help with math problems or just any problems in general. And however, her explanations were not always taken seriously. She sometimes got a lot of backlash, but she did solve the Monty Hall problem. So this is her explanation. So she found that when given the choice of sticking with the answer that they picked originally or switching, the contestant should always switch. So when the contestant first picks a door, there's a 2 out of 3 chance that they're picking a goat, right? So the door, what's behind the door that they picked is probably going to be a goat. So if they pick a goat and then another door with a goat's revealed, the last door has to have a car behind it. So it maximizes their chance of getting a car by switching doors. And keeping the initial door would give the participant a 1/3 chance of winning, while switching would give them a 2/3 chance of winning. So obviously, going with the 2/3 chance is more beneficial. And there is a way to generalize this problem too. There can be more than 3 doors. And here's how this would work. It would work the same way. The contestant would choose a door, and then a goat is revealed from the remaining doors. And then they would choose to either stick with the door or pick another door out of the remaining. And then another goat's revealed, and then they have to make the choice again. And it would keep going until there are only 2 closed doors left. So there can be an n number of doors with an n-1 number of doors that are opened, revealing goats. And mathematicians report that the best method to go about this is to switch the door at the last possible moment. So out of the 2 closed doors, only one would be a car and the other would be a goat. So a way to think about this problem is by using Bayes' theorem, and it represents the problem given that the prize is behind the first door chosen. So here we have the probability that the prize is behind door 1 given the event that door I is opened equals the probability that door 1 contains the prize times the probability that the host opens door I given the fact that the prize is behind door 1 all over the probability that the host opens door I. So, as you can see, there are an infinite number of ways to go about the Monty Hall problem.